start in a new topic, which is induction machine. طبعا I know you already learned the induction machines or induction motor, specifically induction motor in EE360 course. طبعا we should build on this course. However, we are going to refresh your knowledge again, and we are going to review the main important parts you already had it in 360 and continue in the new topics in our course. We are going to focus, شباب, for induction motors on speed control and braking. These are the most important parts you need in industry, and how we can do this by using power electronic converters. This is the main task of this chapter. So these slides here, we have the objectives, which are to understand the construction of three-phase induction motor, to understand the operation principle of the induction motors. طبعا كل ده as a revision, to deduce the equivalent circuit, to learn the power flow, to drive the induction motor torque speed characteristic, learn the performance of induction motor, drive maximum torque equation of induction motor. طبعا الكلام ده شباب as I said, you already learned all of this in 360. However, you are going to fast review these parts just to refresh your knowledge. As an introduction, شباب, we discussed before, induction motor is the most used motors in our industry now because of the cost. It's cheaper than other motors. Efficiency is high. Single supply, it doesn't need two supplies like based field synchronous machine or like DC motors like separately excited, for instance. So it's only single supply. So all of these are advantages for induction motor. For that, it's preferred over lots of motor types. However, as we discussed recently, permanent magnet synchronous motor is higher efficiency and preferred compared to induction. Also, switch reluctance motor is preferred compared to induction, but this is not yet exist in our industry. It's just in the investigation steps now. Type. So the induction motor is the most rushed and most widely used in our life. The induction motor is considered as the black horse of the industry. The alternating current is supplied to the stator winding directly and to the rotor winding by induction. This is why, شباب, we said it's induction motor, because it has only single supply, and the rotor circuit will be induced using induction, by self-induction. So there is no supply for rotor circuit, and this is an advantage for this type of motor. Hence, the name of induction machine comes from this theory. The induction machine also can operate both as motor and generator. طبعا يا شباب, we agreed that all of machines can work as motor and generator. طيب, what exists in our industry? Is it working mainly as a motor or generator or both? ها شباب?
Motor.
Actually, motor is much used. You are right. However, we have also some induction generators as well. It's used in wind energy applications. We have two types of induction generators, which are self-excited induction generator and double cage induction generator, and both of them have been used a lot in wind energy applications. And inshallah, we will discuss later the different types of wind energy generations, and we will find that we have two or three types are based on induction generators. Okay, شباب? Right. So we can find this type of machine working as a motor and generator in today's application. Right. The induction machine is extensively used as a motor in many applications. The induction generators are mainly used for wind energy applications. The induction motor is used at various sizes. This is very important, شباب. You can even find induction motor as even three-phase with very small rating in fractional horsepower. It exists in industry. So this is very important for induction machine. You can find fractional horsepower to tens or hundreds of horsepower. Applications in industry like pumps, fans, compressors, paper mills, textile, and so Fourth, all of these are prefer the induction motor in operation. Also, linear versions of induction machines have been or has been developed primarily for the use of transportation systems. We discussed in the last topic of synchronous machine, we have linear synchronous motor. Also, we have linear induction motor, which is used in transportation systems. So this is just a brief introduction about the induction motor. Again, I'm going to discuss this part fastly because you know most of this information before. Stator and rotor, these are the main components of induction motor. طبعا يا شباب, when we say the components of induction machine, we have mechanical parts, we have electrical parts. Mechanical parts, we refer to the structure of the motor, which is composed of stator core, rotor core, shaft, okay, bearings. All of these are the mechanical structure. And we have also electrical structure, which are the windings. So, firstly, from the stator, which is the stationary part of the machine, stator is composed of laminations of high-graded sheet steel. طبعا it's made of sheet steel يا شباب, not a core or not a complete material, يعني core without sheets, because this is very important to reduce the eddy current loss, okay, and reduce the core losses of the machine. So it's very important to make the machines as sheets, not a complete core. So this core, we will have some slots inside. Okay, as you can see here, we have slots, and these slots are used to both the windings on it. And you have the windings here, which are the armature winding. Okay, these windings carries three-phase AC supply, and it has to be shifted by 120 degrees. So this is the main construction of the stationary part as a mechanical core and windings. Right. For the rotor, we have two different shapes, شباب. We have one shape which is a squirrel cage, which is like that. This squirrel cage is just made by bars, and these bars are shorted from both of sides by two rings like that. So this is called squirrel cage construction. So the rotor consists of laminated ferromagnetic material with slots cut on the outer surface, not the inner surface like in the stator. The rotor winding may be either two types, which are squirrel cage. Okay, as we can see here, this is a squirrel cage as dumbbell. It can be installed on the top of the rotor, or it can be inserted like that. تمام يا شباب? Can be inserted like that in the machine. And the bars are shorted from the two sides by means of metal rings or cover rings. The other shape, which is a wound rotor or slip ring rotor, for this type of شباب, you will find that we have normal windings, coils or wires, and these wires are soldered on three rings. It's called slip rings. So for this type of شباب, because we have rings and we need to connect this winding to outside or make a short circuit on it, why we need to connect these windings outside? This is for the purpose of speed control and machine control. We are going to discuss this later, inshallah. But for now, you have to understand that the three coils or three-phase windings are wound type and soldered on three different rings. Each ring will be considered as one phase. تمام يا شباب? So this is the shape of wound rotor يا شباب, not squirrel cage. And here there is so this is wound induction motor type. For the theory of the operation, we discussed recently in synchronous machine the rotating magnetic field relation, the analytical relation of the rotating magnetic field, which was 3/2 multiplied by n I maximum cosine omega t plus theta. This was the rotating magnetic field, and we said because it's sinusoidal wave, so it's rotating. Now we can describe the operation or the rotating magnetic field graphically, not analytically. If we have three phases like that, let's see together how the field is traveling to construct a rotating field in our machine. For instance, شباب, for the three phases, assume that at instant t0 here in this instant, you will find that IA is maximum, IB and IC is minimum and is negative with this value. So IA is maximum, this is IA, or this is the field due to IA, and the field due to B and C is negative. So you know B is at angle, for instance, 120 like that, so it will be minus. So it's minus 60 now. And FC, if it is, for instance, at angle minus 120, so it will be plus 60 like that. When you summate the three vectors now, it will be a vector in this direction, which is nothing but 3/2 F max, which is the same as what we already get in the analytical form. Okay. This can be, شباب, achieved at any time. Now we achieve this at T0. If you make the same at T1, you will find that A is 0, B and C, one is positive and the other is negative, and you will get the same result but at different angle. Let's see together for T1. So at T1, you will have B and C, and the summation will be in this direction. As you remember, it was in this direction at T0. Now it became in that direction at T1. After that, at T2, you will find the resultant vector will be here. So as you can see, it's traveling or rotating. For that, we call it rotating magnetic field. تمام يا شباب? So this is the graphical derivation for the rotating magnetic field. For the operation of three-phase induction motor يا شباب, actually there is a video here, but I will leave this for you to see this video to understand in more details or on animation way how the induction motor start and rotate. But firstly, I will discuss it here for you. If we have a part of rotor like that, and these are the rotor windings, and we have here parts of stator core, and due to rotating magnetic field we have here S, and in the opposite side at the bottom of the stator and rotor we will have also pole M at certain instance. تمام يا شباب? So this is at a certain instant. As you can see, flux is moving from down to up, from N to S, and it will cut the rotor windings. When the rotor windings is cut by means of flux, it will generate a flux. Sorry, firstly, the windings on rotor are short circuit. So when you have field cutting a short circuit windings, it will generate EMF, and this EMF will produce current. Why the current will move? Because it's short circuit. If you have a closed circuit, so it's expected if you have EMF, a current will flow. And do you remember the experiment maybe in primary schools where you have a wire connected to lamp and you move this wire in a magnetic field? What was happening يا شباب? What was happening when we have wire connected to a bulb and this wire is moving in a magnetic field? What was happening at the time? Do you remember?
It will light.
Exactly, the bulb will light. تمام. Why? What has happened? There is an EMF, and due to the short circuit or closed path, a current will flow. The same is here يا شباب, because the rotor circuit is short circuit, so a current will flow. But when we have current, the armature reaction, when you have current here moving in the conductor, so this is going to make flux around this conductor. And this flux will have a component like that يا شباب in this direction if the current is going inside the page like that. Okay. So as you can see, the flux around the conductor due to the armature reaction is like that, and the total flux or the upcoming flux from the stator is moving from N to S. So what will be the net flux? If we can see, we will find that the component of flux in this direction will be smaller than the component of flux in that direction. طبعا component of flux here is higher than that side. It will make a force on the conductor. تمام يا شباب؟ This force will move the conductor from this side. طبعا this conductor is one part of turn. يعني we have another conductor in the bottom on the same turn, and the current is in the opposite direction compared to the upper one. And we will find that it has force in the opposite direction. So you have force in that direction here, and the force in the top in that direction, and you have already a rotor with a certain radius. So a torque will be developed here يا شباب due to the two forces with a distance in between. So there will be a torque that will start moving the machine. Right, now we understood how the machine is starting, but we would like to understand how the machine will reach to steady state. Starting, it is not meaning it's a steady state. Starting, it means if the machine has flux, for instance, moving with a speed of ns equals 120 f over number of poles. Assume it's 1800 if we have number of poles يعني for 4-pole machine. So we have ns equal 1800 rpm. So the flux is moving with 1800 rpm. However, you start moving the rotor. It may be several rpm or 100 rpm, for instance. What happened in order to reach to steady state? Actually, the frequency of the flux which is moving here is 1800 rpm or 60 hertz, and the frequency.
Doctor,
تفضل.
what you mean it is when the machine is starting, it's operating at transient until it's reached the steady state? Or?
Yes, this is the meaning of transient. Transient, it means the period or the starting period when you apply the supply to the machine up till reaching to the steady state. This period is called transient. يعني if you turn on a motor, it will not reach to steady state at 0 time. It will take some time. It's like your car. If you started your car and start moving, and the road is 120 kilometers per hour, for instance, can you move with the car in 120 kilometers per hour from the first instant, or you increase the speed of the motor of the car gradually to reach to the rated speed?
Gradually.
Gradually. It's the same also for any electrical motor. You have to, or the motor, yani increase the speed gradually up till reaching the steady state operation. All of this period is called, all of this period is called transient period or starting period. Okay. So now we are discussing about the period of starting, the transient one. So as we agreed now, the flux which is coming from the stator is moving at 60 hertz or 1800 rpm if it's 4 volts, and the current which will be generated in the rotor يا شباب. What is the frequency of this current? ها شباب, when the machine is at standstill, what will be the frequency of the current?
I think the same as the
exactly the same. It's like transformer now. صح ولا غلط? This is like transformer because there is no motion. طيب, after we have a motion here, the cutting speed of flux on the conductors will be smaller than the synchronous speed. يعني, let's make it in numbers. Flux is moving by 1800 and the rotor is moving by 100. So what is the cutting speed now?
The difference.
The difference, 1700, exactly.
Yeah.
This is right. So if you have 1700, what will happen to the EMF and the current and so on? It will be reduced. صح ولا غلط يا شباب؟
Yes.
Because the speed has been reduced. So the force will reduce. Type, what will happen when you reach to a rotor moving in 1700? The force will reduce more. صح ولا غلط? The force will be very small, and so on. So what will happen if the rotor moves at the same speed of synchronous speed? What will be the cutting speed in this case?
0.
0. Exactly. So if the speed of the rotor reached to synchronous speed, the cutting speed will be 0. This is logic. If you are moving at the same speed with another object, the relative speed will be 0. This is logic. Type, if we have zero cutting speed, which is the speed of electricity of the rotor circuit. So what will be the EMF and the current? If you don't have any cutting flux, what will be the induced voltage now?
0.
It will be 0. So if you don't have EMF or current, this is going to make no flux for the rotor, and this will produce 0 force. صح ولا غلط يا شباب؟
Yes.
جميل. طيب if you have 0 force, what will happen? The motor should start reducing its speed in order to shut down or off. مظبوط. And if it is happened, there will be a difference again. يعني, for instance, when the speed will be reduced from 1800, it will reach, for instance, 1790 or 1780. So there will be a difference again, and there will be a cutting speed and a force moving the conductor again. صح ولا غلط؟ يا شباب, is it clear?
Yeah.
So the induction motor speed will be in oscillating manner all of time between 2 points يا شباب. These 2 points are the synchronous speed and one speed below this value. The average of these 2 speeds is the motor speed. We consider the motor speed as the average between the synchronous speed and the lower speed of the motor moving. So this is called the induction motor speed. For that, we have a relation which is called slip. This is now the slip which is representing the per unit cutting speed and which represents the motor speed average. So if you have slip in RPM of, for instance, 100 RPM, so this means the rotor is moving by 1700 RPM and synchronous speed is 1800. تمام يا شباب? Is it clear now? So the slip represents the average of the cutting speed. Average of the cutting speed. It can be represented in RPM or in per unit. طبعا in per unit we should refer to the synchronous speed. So this is the idea شباب for the operation of the induction machine. طيب.
Sorry, doctor.
تفضل.
Actually, I saw in the nameplates usually they didn't write it 1800. Usually they write it, for example, the RPM of this motor 1780 or 1750.
Yes.
Because
this is the full load speed. يعني if we said this motor is moving at 1700, this is on nameplate data, this means this is the rated speed of the machine. تمام? Which is considered as the average machine speed at full load.
that means in the reality it will reach 1800, then it will slow down.
All of time, the induction motor speed is oscillating between 2 points, and the average of this is called slip. تمام? This is
okay.
in terms of transient during certain period. However, when you look for a device, you look for the general performance. يعني, let me give you a small example. If you move with your car in a crowded area and you increase and decrease your speed, however, by the end of your way, you can say, I take certain time, and you know the distance, so you can use the distance and time to get your average speed. Okay? Is it mean that you are moving on this speed during all of way? It's not the case. صح ولا غلط?
Yes.
Yeah, so this is the meaning of having average, because you know for electrical systems, you have very fast systems, and you cannot recognize this by your eye. So we can say we have a speed of motor speed. However, in reality, it's oscillating between 2 points as we discussed, but we cannot recognize that because it's very fast. يعني for instance, شباب, the AC lamps, the AC bulbs, you know, it's supplied here, for instance, in case A, supplied by 60 hertz. Type for 60 hertz, شباب, how many zero crossing per second for the sinusoidal wave?
120.
120 zero crossing per second. Do you see the lamp turn it off for 120 times per second?
Sure, we
Do you
cannot.
recognize that? You cannot recognize that. However, in reality, it's turned off for 120 times per second. But our eyes cannot recognize that. The same is also for any electrical system, like motors here. So we represent the motor by certain value, which is considered as the average speed of the machine. تمام؟ On this, شباب, we have many speeds now. We need to recognize these speeds. First, we have synchronous speed, which is the speed of flux in our machine. طبعا flux, either for rotor or stator. For stator, it's very clear because it depends on the supply frequency and the stator current. But why the rotor flux is the same frequency? Rotor flux is the same, يا شباب, because we measure the speed from stationary place. يعني, if we go to the figure here again, you have here rotating flux around the rotor conductor, which is depending on the frequency of the rotor current. صح ولا غلط شباب؟
Yes.
طيب, assume that rotor current frequency is small and the RPM of this flux now is, for instance, 500 RPM. But the rotor itself is moving with the difference. صح ولا غلط? So if you are measuring from stationary part here, you will see the flux of rotor is moving with the same of synchronous speed. صح يا شباب? So for that, we can say that all machine fluxes, stator or rotor flux, are moving with the synchronous speed. So the machine flux are moving with synchronous speed. The rotor speed, which is the average speed as we discussed, depends on the difference between stator flux and rotor frequency. Stator frequency and rotor frequency, which is F1, stator supply frequency, and F2, rotor current frequency. And this is called N. What will be the value of N now? We can say N equals Ns minus N of cutting speed. The cutting speed, finally, which is N2, or we can call it slip speed, depends on the cutting speed, which is Ns minus N of the rotor. So now, يا شباب, we have two main frequencies. Frequency F1, which is the supply frequency. Frequency F2, which is the rotor current frequency. And we have three different speeds are important. Synchronous speed, which is the flux speed. We have rotor speed, which is N equals NS minus N of slip, or S multiplied by NS, okay? And we have cutting speed, which is S multiplied by NS. So these are the different speeds we have in induction motor. However, most of the time we are going to take care about the rotor speed, which is equals to NS, sorry, 1 minus S multiplied by NS. So this is all of time the rotor speed that we are going to take care. So this is now N. This is the RPM of the motor. تمام يا شباب؟ In terms of electrical circuit, now we need to make a model or mathematical model and equivalent circuit for the motor in order to analyze the performance of this motor. This is all of time the aim of making circuit for any electrical system. So we agreed that we have now N, which is the motor speed, N equal 1 minus S multiplied by NS, and we have N2, which is the rotor, which is the cutting speed, which is depending on F2, 120 F2 over number of poles, or we can say it's equal to NS minus N, or equal to S multiplied by NS, and all of these are possible. تمام. So this is a derivation of N2. Now what we need to provide the equivalent circuit, we need to recognize the frequency and EMF for these windings. If we have stator with frequency F1, what will be the induced voltage at the rotor side? We expect to have E2 equals 4.44 multiplied by F2 N2 phi, which is peak flux, multiplied by K winding. طبعا the speed of the EMF will depend on the current frequency of the rotor circuit, which is F2. طب what is the relation between F2 and F1 يا شباب? We said F2 equals SF1, صح؟ F2 equals S multiplied by F1. If you substitute here in this equation, you will find that the relation is 4.44 SF1 into phi K winding. So it's S multiplied by E2, where we can say now 4.44 Fn phi K as E. So we can say E due to motion equals to S multiplied by normal EMF. Right. Why we need that? We need that in order to make an equivalent circuit. But firstly, let's have very fast example here, just to refresh your knowledge. Here we have 460 volt, 100 horsepower, 60 hertz, 4 poles induction motor, delivers rated output power at slip of 0.05. So this is slip يا شباب دايما امبريونيك. ترمين يا شباب اول حاجه determine the synchronous speed and motor speed. ها يا شباب مين يقول معايا what will be the synchronous speed now؟ ها NS equals what؟
1800.
120 F over number of poles. صح كده؟ We have
Yes.
4 poles. We have 60 hertz. صح؟ So 120 multiplied by 60 over number of poles, it will be 1800 RPM. ممتاز. طيب حد تاني يا شباب. What is the motor speed؟ N. حد تاني يقول يا شباب. What is the motor speed? 1 minus S multiplied by NS. So we can say now 1 minus 0.05 now
1710.
جميل. 1710. جميل. So this is now the motor speed. Number B, speed of rotating air gap field. احنا قلنا اي سرعه فيلد تبقى يا شباب
Synchronous.
Exactly. So this is synchronous speed. Frequency of the rotor circuit. The frequency of the rotor circuit. Rotor circuit means the current frequency, شباب. The current in the coils of rotor. What will be the frequency of this current?
57.
we said F2 equals SF1, not 57. It should be very small at steady state. Almost يعني around DC, يعني 1, 2 hertz, 3 hertz, like that. So it's 0.05 multiplied by 60. So it's 3 hertz. صح يا شباب؟
Yes.
Number D, slip in RPM. What is the slip in RPM now يا شباب? We can say SNS, صح? Which is the difference between rotor speed and synchronous speed. So we can say it's 90 RPM. Type here, speed of rotor field relative to it means relative speed. But we know that speed of any field is ns. But relative to, so we have to subtract from the other object. Relative to rotor structure, so what is the speed of rotor structure, Shabab?
17 and 10.
Exactly. So we can say now speed of rotor field relative to rotor structure is ns
90.
minus nr, which is 90 RPM. Type speed of rotor field relative to stator structure. Stator structure is zero speed, صح ولا غلط?
Yes.
So
Stationary.
the answer of this one is ns, because stator structure is already stationary part, so the field ns, so the relative speed now will be ns. Type related to stator rotating field. So stator or rotor field related to stator field, what will be the speed now?
0.
Exactly. ممتاز. جميل جدا. طبعا the aim of this question is nothing but recognize the different frequencies and speed control. Finally, what is the rotor induced voltage at the operating speed if the stator to rotor turns ratio is 1 to 0.5? So we have the turns ratio here. We need just to calculate the value of EMF. So simply we can say E2S equals to S multiplied by E2. So it's S slip multiplied by N2 over N1 multiplied by E1. This is to refer the voltage to the rotor side. So it's 0.05 multiplied by 0.5, which is value of N2 over N1 multiplied by the line voltage over square root of 3. So this will be the EMF at the rotor side. The equivalent circuits. Based on our discussions, Shabab, we will drive equivalent circuit at stationary operation. Then we will conclude the equivalent circuit at moving. So first at stationary, it's or at standstill, it's nothing but the equivalent circuit of three-phase transformer. صح ولا غلط؟ يعني if you have no motion for induction motor, so you can represent the windings as three-phase transformer, because you have primary winding and secondary winding, you have primary core and secondary core, and the same are in the induction machine. We have stator windings and stator core, we have rotor windings and rotor core. So we can say the equivalent circuit at standstill is like that. We have R1, X1, this is for the stator side, R core, XM for magnetization branch. So this now represents the stator circuit. For the rotor circuit, شباب, at standstill, you know rotor is short circuit, so we have windings of R and X. However, take care, X is frequency dependent. So if there is no motion, it will be X. However, if the motor starts moving, it will be S multiplied by X. صح ولا غلط شباب? Because X equals 2 by FL. So if you move the machine, frequency will be F2 for the rotor circuit. So we expect the value referred to F1 is S multiplied by F1. So the relation will be 2 by F1 L2 multiplied by S. So we can say now SX2, where we can represent X2 all of time in terms of F1. So this will be the circuit of rotor. The EMF is SE2, the reactance is SX, and the resistance is R. Now, if you would like to calculate the current here, I will be equal to the voltage over impedance. So it's SE2 over R2 plus JSX2. If you divide S2 in numerator and denominator, you will find the resultant is E2 over R2 over S plus JX2, which can be represented as voltage source, like that, and impedance with this value. JX2 is a coil, has reactance X2, and R2 over S is variable, so we have a variable resistance of R2 over S. So this now, شباب, represent the equivalent circuit of rotor part. طبعا we can say R2 over S equals to R2 over S multiplied by 1 minus S plus R2. If you summate these two terms, it will give you the same term R2 over S. Why we need to make it like that? This is very important for the power flow, because in power flow we have losses and gained power. R2 represent losses because you will have copper loss as I square R. However, R2 over S multiplied by 1 minus S will represent a gained power. So this is very important. For that, the equivalent circuit, as we can see here, is R1, X1, RC, XM, X2 prime, R2 prime, R2 prime over S multiplied by 1 minus S. So this is the exact equivalent circuit of the induction motor. For simplicity, we are going to make some assumptions in this circuit to be easily analyzed. For the power flow, شباب, you have P input for any three-phase system, square root of 3 V line, I line, cosine theta, and theta, all of time, شباب, cosine theta is the angle between phase volt and phase current, okay, which represent the power factor angle. This power will be entered to the machine, and you will have some stator copper loss and core loss, which are considered as stator losses. Then the remainder power will move from stator to rotor, which is called air gap power. We can say air gap power now equals the input power minus this power, core and the copper. So we can say from the equivalent circuit, if we go to again to the equivalent circuit, you will find that we have here R1 and RC, which representing copper loss for stator and core loss. So the remainder of power, شباب, will go the remainder resistances of the circuit. صح ولا غلط? So we can say now B air gap equals I square multiplied by R2 plus R2 over S multiplied by 1 minus S, which is I square of I2 square multiplied by R2 over S. It's the same. So this is the air gap power. For the rotor circuit, we will lose some copper loss on the rotor resistance. The remainder power will be called B converted or B mechanical. Converted or mechanical. B mechanical equals I square R over S multiplied by 1 minus S. Or we can call it as 1 minus S multiplied by B air gap. And B2, which is the copper loss on rotor circuit, equals I square R or equals SB gap. Yani if we compare B2 with B gap here, we can say B2 equals SB gap. The remainder of power, شباب, which is B converted, will move through the rotor core, and we will lose some extra power due to friction and windage. This power is considered as mechanical loss, which can be considered as T friction multiplied by omega. And the remainder, and we will have also some stray losses. And the remainder of power will be P output, which is torque load or torque shaft multiplied by omega M, which is the rotor speed. طبعا take care. All of power up till the air gap are considered moving with the speed of synchronous. So we can say power A gap equal torque developed or electrical torque multiplied by omega synchronous. Okay, شباب. However, after that, the speed of the rotor will be here. So this is omega M, not omega synchronous. Okay. So this is شباب regarding the power flow. And inshallah, we will continue from this part from the next class up till finishing the introduction and then moving inshallah for the new topics. Any question يا شباب in our class today? Everything is clear? طيب جميل. نراكم ان شاء الله الكلاس القادم. يعطيكم العافيه يا شباب.
اليوم الدكتور هيلب سيشن ها؟
اليوم ان شاء الله في هيلب سيشن at 7:30 p.m. ان شاء الله.